Assalamu alaikum dear students. In previous video lecture we discussed the angle between the two non-vertical lines in terms of their slopes. Now today we shall discuss the collinearity of 3 points in plane. Now you know that the 3 points are said to be collinear in plane if they lies on the same line. Also you know that any two points in plane are always collinear, because if we have any two points, we can pass through a fixed line through these 2 points. So this means that these points lies on this line, which implies that 2 points are always collinear. But if we consider 3 points, they may or they may not be the collinear. So we have to find the necessary and sufficient condition for three fixed points such that these three fixed points are collinear. Now let's assume that 3 points are P of x1 y1, Q of x2 y2, and R of x3 y3 be any 3 points. Now these 3 points are collinear if and only if they lies on the same line. Now when they lies on the same line, that is they lies on line PQR, that is this very line. Now also you know that two lines are parallel if and only if their slopes are equal. Now here we have two types of parallel lines, one which do not intersect, second one which intersects, and they intersect at infinitely many points, which implies that actually they coincide with each other. Now in both cases the angle between these two lines is 0, which implies that they are parallel. Now here we have line PQ and we have line QR. Now when these 3 points are collinear, this means that they lies on the same line, which implies that slope of this PQ equals to slope of QR, because these two lines PQ and QR coincides with each other, means they intersect at infinitely many points. Hence the slope of PQ equals to slope of QR only when PQR are collinear or PQR lies on this line. So this means that necessary and sufficient condition for these 3 points to be collinear is that the slopes of PQ equals to slope of QR, which implies that slope of PQ equals to slope of QR. You know that the slope of a line which passes through two fixed points is, here we have line PQ which with points x1 y1 and x2 y2, then its slope is y2 minus y1 upon x2 minus x1, and this QR on RQ equals to y3 minus y2 upon x3 minus x2. So this is the necessary and sufficient condition for these 3 points to be collinear. Now if these 3 points, if these 3 points do not lie on the same line, this means that this y2 minus y1 upon x2 minus x1 is not equals to y3 minus y2 upon x3 minus x2. So let's start this exercise 10.1. Now first question of this is, draw a quadrilateral in plane whose vertices are this, and this. Also find its area. You know that the quadrilateral is a closed polygon formed with 4 straight lines. So that is why we have here 4 these vertices. Now how to draw this? Let us draw a plane. You know that in plane we have 4 quadrants. Quadrant first, in which x and y are positive. Quadrant second, x is negative, y is positive. In third quadrant, both are negatives, while as in fourth quadrant, x is positive, y is negative. Here first point, let's assume that this point is A. Its coordinates are -4, 5. This means that this point lies in second quadrant, that is this very point, point A. Similarly 0, 7. Now here x-axis is 0, y is 7, and y is positive, which implies that this point lies on y-axis but on the above side of the x-axis. This means that this is point B. 0 7. Now similarly third point 5 minus 5 lies in fourth quadrant, because in fourth quadrant x is positive, y is negative. Let us say that this point is point C, which is 5 minus 5. Similarly minus 4 minus 2 is the point in the third quadrant, and name this point as D, which implies that D is minus 4 minus 2. So this means that these are the 4 points. When we join these points, we get a required quadrilateral, that is A B C D A. Also let us join BD or AC. Here I join BD, so which implies that area of this quadrilateral equals to area of triangle, this above triangle ADB, and area of triangle DCB. You know that the area of triangle with vertices x1 y1 x2 y2 and x3 y3 is 1 upon 2 positive value of, that is modulus of, x1 into y2 minus y3 plus x2 minus x2 into y3 minus y1 plus x3 into y1 minus y2 square units. So substituting the value of a, b, c, d in this equation, you get the required area of the given quadrilateral. Now question number 2 of this exercise. Now the base of the equilateral triangle with side 2a lies on y-axis such that the midpoint of the base is origin. We have to find its vertices. Now you know that the equilateral triangle is that triangle whose this whose sides are equal. Now this is the base lies on this this y-axis, so this means that this is the base. Also its length is 2a, and the midpoint of base is origin, which implies that a from 0 oh a equals to a, while as oh b equals to minus a, which implies that distance of AB equals to 2a, means it is a base. You know that in equilateral triangle the perpendicular bisector is actually the angle bisector in equilateral triangle, which implies that the third vertex of this triangle lies on this x-axis, because here the perpendicular bisector is either the positive x-axis or the negative y-axis. Also the coordinates of this point A is 0a, while as coordinates of B is 0 minus b, because they lies on y-axis. Now here let C and C dash, which implies that either the required triangle is ACB or AC dash B. Now this C or C dash lies on x-axis, which implies that its coordinates are of the form of x comma 0. So first one is minus x0, which is C dash. Second one is C, which is x0. Clearly AC equals to 2a, because distance between AC is 2a, because it is equilateral triangle. Now what is AC? Now coordinates of C are x0, which implies that under root of x minus 0 square plus 0 minus a square equals to 2a, because coordinates of A are 0a, while as coordinates of C are x0. By using the distance formula we get this. Now taking squares on both sides, it is x square plus a square equals to 4a square, or simply x square equals to 3a square, or x equals to plus minus or square root of 3 into a. So this means that the required vertex of a triangle is x0. If we take positive, it is root 3a0. Hence C equals to x0 equals to root 3a0, or C dash equals to minus x0 equals to minus root 3a0. Hence the vertices of triangle are 0a, 0 minus a, minus root 3a0, that is triangle ABC dash, or 0a, 0 minus a, root 3a0, that is triangle ACB. Hence for in this situation we have there exists two triangles, either ABC or ABC dash with given with these called this now we have to find the distance between P of x1 y1 and Q of x2 y2 if PQ is parallel to x axis. Now here PQ is the given line as shown, which implies that PQ is here parallel to x axis. When PQ is parallel to x axis, which implies that y1 equals to y2. Now you know that the distance between 2 points PQ is root of x2 minus x1 square plus y2 minus y1 square. Now substituting y equals to y2, which implies that this y term will cancel, that is it is 0 because y2 equals to y1. Hence it is simply under root of x2 minus x1 cos square and root cancels, we simply get x2 minus x1 but in modulus, that is unitus. Hence when PQ is parallel to x axis, which implies the distance between P and Q is x2 minus x1. Similarly, if PQ is parallel to y axis, in this situation we have situation like this. Here x1 equals to x2, which implies that PQ by substituting this we get y2 minus y1 unitus. Hence this is the situation, this is the distance when we consider PQ parallel to y axis or PQ parallel to x axis. Now find the point on x axis which is equidistant. Equidistance means distance between these 2 points must be same, that is it's the midpoint from the points 7, 6 and 3, 4. Now let a of x comma 0 be a point on x axis, because any point on x axis is of the form of x comma 0, which is equidistant from this b of 7, 6. Name this 7, 6 as b and c of 3, 4. That is this situation. Here a is equidistant from this b and this c, which implies that ab equals to ac by question, because it is equidistant from b and c. Now using distance formula, which is simply root of x minus 7 square plus 0 minus 6 square equals to under root of 3 minus x square plus 4 minus 0 square. Now taking squares on both sides, we simply get x minus 7 square plus 6 square equals to 3 minus x whole square plus 4 square. Now simplifying this, we simply get 60 equals to 8x or x equals to 60 upon 8. Hence 60 upon 8, 0 is the required point. Now clearly this point lies on x-axis, this x-axis, because y is 0. So this is the point which is equidistant from 7, 6 and 3, 4. Inshallah tomorrow we will continue this very exercise. So thank you.